Okay, the next method is IRR for point D. So to remind you a bit, the IRR or internal rate of return, if we're calculating the IRR, it means we are looking for a rate which it makes our NPV become zero. And in this case, we're gonna find the IRR using interpolation method. And before we use interpolation method, we have to make assumptions. Here, I assume that the IRR is 10% and the IRR is 20% for both project A and project B. And then after we make our assumptions, we need to calculate the NPV using this rate as the discount rate. For using the NPV, the first thing we have to do is to calculate the PVCF. So the PVCF for the project A when the rate is 10% is this cash flow for the year 1 of the project A divided by 1 plus 10%, which is the discount rate, in the power of 1, since this is we're calculating the cash flow of the year 1, plus the cash flow of the year 2 divided by 1 plus our assumed IRR or 10% divided by 2, not divided, but in the power of 2, since we're calculating the cash flow of the year 2, and so on for the third year and the fourth year, and then we get our sum PVCF. It is 363,445.12, and our investment, it is stated in the question, it is 300,000, and the NPV is we're subtracting the PVCF with the initial outlay, and then we get this 63,445.12 for the NPV for project A if the IRR that we have assumed is 10%. And then we're going to do the same with the second assumption for project A, which is we assume that the IRR is 20%. So we have to calculate the PVCF and the NPV at the end using this 20% as the discount rate. So the PVCF for this project A when the IRR is 20% is the first year of the cash flow of the first year divided by 1 plus 20%, which is our assumed IRR, in the power of 1, since we're calculating the first cash flow, plus the second cash flow or the year 2 cash flow divided by 1 plus our assumed IRR, which is 20%, in the power of 2, because we're calculating the cash flow of the year 2, and so on for the year 3 and the year 4 are the same. And then we get our sum PVCF is 268,402.78, and then the initial outlay is 300,000, and we subtract it to get our NPV. And the NPV for project A, if the IRR is 20%, is minus 31,597.22. And then after that, we summarize all of the calculations above. We write down that the IRR we assumed is 10% and 20%, and the NPV of the IRR 10% is 63,445.12, and the NPV when the IRR is 20% is minus 31,597.22. And we put our IRR as the X, and it is in the middle, because remember that when we are calculating IRR, it means that we will make our NPV 0, and 0 is in between this, is in between these numbers, the 63,000 and the minus 91,000. So we can calculate using the interpolations. We have to write down with this formulation. The 10%, which is our first assumed IRR, minus our actual IRR, which means which is the rate that we are looking for, divided by the 10%, our first assumed IRR, minus our second assumed IRR, which is 20%. Equals to the NPV of the first assumed IRR, which is this 63,000 minus 0, because remember again, if we're calculating the IRR, we make the NPV become 0. So minus 0 divided by the NPV for the IRR is 10% minus the NPV when the IRR is 20%. And we substitute all this, and then we get our IRR equals to 16.68% for project A. I'm gonna mark this. And for project B, we're gonna do exactly the same way. My assumption is the IRR 10% and the IRR 20%. It is the same with project A. And then we have to calculate the present value of cash flows. This is the first cash flow of the project B divided by 1 plus the assumed IRR, which is 10% in the power of C1. C1 is 1, since we're calculating the cash flow of the year 1, plus the cash flow of the year 2 divided by 1 plus assumed IRR, which is 10% in the power of D1. D1 is 2, because we're calculating the cash flow of the year 2, and so on for the third and the fourth year of the cash flow. And then we get 47,885.39 for our sum PVCF, and our initial outlay is 40,000. It means that our NPV is 7,885.39, because we subtract the sum of PVCF and the initial outlay, and then we get this number of NPV. And then for second assumption of project B, the IRR is 20%. We're gonna calculate the PVCF. So the PVCF for the second assumption of project B is the cash flow of the project B, the first cash flow of project B divided by 1 plus the assumed IRR, which is 20% in the power of 1, because we're calculating the cash flow of the year 1 plus the cash flow of the year 2 divided by 1 plus 20% in the power of 2, since we're calculating the cash flow of the year 2, and do the same with the third and the fourth year of the investment. And then we get 39,646.99 for the sum of PVCF, and the initial outlay is 40,000. It means that our NPV is minus 353.01. And then we summarize all our assumption and calculations here, and then we can immediately look for the IRR using interpolation method. So the 10%, the first assumed IRR minus our actual IRR that we are going to find out, divided by our first assumed IRR, which is 10%, divided by our second assumed IRR, which is 20%, equals to the NPV when the IRR is 10%, which is 7,000, minus 0, because we are calculating the IRR. It means we are making our NPV become 0, divided by the NPV if the IRR is 10%, and minus the NPV when the IRR is 20%. And then we calculate it, we substitute it, and then we get our IRR for project B is equal to 19.57%. Okay, so from the IRR, it means that the project B with higher IRR is more preferable to the investor. So we're going to choose project B based on the IRR. Okay, the next one, we're going to calculate profitability index or PI. The formula of the PI is actually the same with the NPV, but instead of subtracting the sigma of PVCF, we divided it with the initial outlay. So the PVCF we have calculated in the present value in point C, so we can just refer to it. And then the initial outlay is 300,000 for project A, and then the PI is the sum of PVCF divided by initial outlay, and then we get this 1.04 for project A. And for project B, also the same. The sigma of present value cash flow, we have calculated it in the point C for NPV, so we can just refer to it. And the initial outlay for project B is 40,000, and then the PI is this sigma present value of cash flow or PVCF divided by the initial outlay. So we get this 1.09 as the PI. And from the profitability index, we know that the PI of the project B is higher. It means that it will be more preferable for investors. So we're going to accept, or we're going to choose project B based on the PI. The next method is MIRR. So MIRR is basically the same concept with the IRR, but we have to modify the cash flows first using 3 different approaches. The first approach is the discounting approach. It means that we have to discount all the negative cash flows from year 1 until year 2 into the present year or the year 0. But in this case, we don't have any negative cash flows from year 1 until year 4. It means that we can use this cash flows to calculate our PVCF. So we just need to sum all of these cash flows and we get our PVCF. So we get our PVCF 210,000. And for calculating the MIRR, we can use Excel formulation to calculate the IRR using this cash flows, and we get our MIRR equals to 16.2%. And also the same with the project B, we were going to discount all the negative cash flows from year 1 until year 2 until year 4, but we don't have any negative cash flows, so we don't have to change anything. We just have to calculate our present value cash flows by sum all of this, and we get our PVCF equals to 19,500. So the MIRR using the IRR formulations from the Excels is 19.5%. And the next approach is a reinvestment approach. So in reinvestment approach, we compound all of the cash flows. It is either it is negative or positive into the last period of the investment. In this case, we compound all the cash flows from year 1, 2, and 3, except for the initial outlay, to the 4th year period of the investment. And it becomes like this. Because we compound it, it means that we multiply it instead of we divide it. Okay, so the calculations is this cash flow of year 1 multiplied by 1.15. 1.15 is 1 plus our discount rate, which is 15%. It is stated at the questions in the power of 3, because we are calculating the cash flow of the 1st year and we compound it to the last year, which is the 4th year. It means that 4 minus 1 is 3, so in the power of 3. plus the cash flow of the year 2, which is 50,000, multiplied by 1.15 in the power of 2, because we're calculating the cash flow of the year 2, and the fourth year minus the second year, 4 minus 2 is 2, so in the power of 2, plus the cash flow of the year 3 multiplied by 1.15 in the power of 1, since we're calculating the cash flow of the year 3, and 4 minus 3 is 1, so it becomes 1. And we add also the cash flow of the year 4, and we get our modified cash flows for the reinvestment approach is 544,043, and for this reinvestment approach, to get our MIRR, we have to make it equal. The initial investment equals to the modified cash flows divided by 1 plus rate. The rate is what we are looking for now, the MIRR, in the power of 4, since the period of the investment is 4 years, so in the power of 4. And then we substitute it, we get 1 plus r in the power of 4 equals to 1.81, and 1 plus r equals to 1.16, and we get our r, or our MIRR, equals to 16.05%. Also, the same for the project B, we compound all the cash flows from year 1, 2, 3 into the fourth year of the period of the investment period. It means that the formulations becomes like this: the cash flows of the first year of the investment B multiplied by 1.15 in the power of 3, because 4 minus 1 is 3, plus the cash flow for the year 2 multiplied by 1.15 in the power of 2, because 4 minus 2 is 2, and it becomes 2 then, plus the cash flow of the third year, or year 3 multiplied by 1.15 in the power of 1, since 4 minus 3 is 1. And we also add the cash flow of the fourth year, and then we get the modified cash flow for project B using reinvestment approach equals to 75,967, and we have to make it equal again. The initial investment equals to the modified cash flows for project B divided by 1 plus r. The r is what we are looking for, our MIRR, in the power of 4, since the period of the investment is 4. And then we get this 1 plus r in the power of 4 equals to 1.9, and then 1 point r equals to 1.17, and we get our r, or our MIRR, equals to 17.39%. And the last approach is the combination approach. In combination approach, we discount all the negative cash flows into the year 0, and we compound all the positive cash flows to the last year, or the last period of the investment, which is the fourth year. And since we don't have any negative cash flows, it means that we just need to compound all the cash flows from year 1, 2, and 3 to the fourth year, and it's the same way with this one, and we can just refer to the reinvestment approach. We get this modified cash flows for a combination approach, and then we have to make it equal again. The initial investment equals to the modified cash flows divided by 1 plus r in the power of 4, and then we get our MIRR equals to 16.05%. It's basically similar. It's basically the same, not just similar, but exactly the same with the reinvestment approach, since we don't have any negative cash flows, in this case. And For project B is also the same with the reinvestment approach of project B, so we can just refer to it, and it's also the same, and the MIRR is also the same. It is equals to 17.39%, and based on the MIRR, we can see that the MIRR is always greater for project B than project A. It means that we have to choose project B since the MIRR is higher than project A. So for MIRR, we're going to choose project B. Okay, the next question, the last question, is to decide which investment is the best for you to invest. The payback, in summarize, the payback period, choose project B. The discounted payback period, choose project B as well. And the other also choose project B except for the NPV. And now the question is, which investment you have to choose. Do you have to choose the project B since 5 of them said project B is more preferable, or you have to choose project A because the project A has a higher NPV than project B? The answer is you have to choose using or based on the NPV, the higher NPV. It means that you have to choose project A since as I told you before as well in the material video, NPV is the only criterion that is able to rank mutually exclusive projects with the lowest bias. And in this case, project A and project B are mutually exclusive because when you are choosing project A, you can't choose project B at the same time. So it is mutually exclusive. So since the others cannot be used in ranking a mutually exclusive project, it means you have to choose project A because project A has a higher NPV than project B.